What's up everyone, and thank you for choosing to learn with LAM. Today we're going to be going over the different types of concentration with a focus on molar concentration. To start, it should be made clear that whenever we're dealing with concentration, we're always looking at information about the solute per information about the solution. If we go back to our lesson about percent composition and percent yield, we're always talking about the partial over the total, and this is no different. The solute is a part of the solution, which is the total. The first type of concentration we'll look at is called mass volume percent, as you can see pretty plainly from its variable. Luckily for us, these concentrations are named in a way that makes the equation pretty easy to remember. The equation here is mass, and remember that we're always talking about the solute on top, and its unit is grams. We'll divide that by volume, and that's always of the solution because it's on the bottom, and its unit is milliliters, and then times 100% because it's a percentage. Pretty straightforward, right? Let's try another one. This one's called volume percent. I'll give you a few seconds head start to see if you can guess what the equation is. All right, here I go. The equation is a volume of solute over volume of solution times 100%. Now, notice that unlike mass volume percent, I didn't give you any units for this equation. That's because the units don't matter as long as they're the same on top and on bottom. As long as they're the same, so both milliliters or both liters or both gallons, the units will cancel out, so we can use whatever's most convenient based on the question we're doing. This applies to mass percent as well, which is of course mass of solute over mass of solution times 100%. As long as I've got the same mass units on top as I do on bottom, we're all good to go here. Now, these next two are a lot like mass percent, but they're used to communicate really small amounts. They're not percentages, which sometimes gets people a little bit, but I think we can work our way through them. The first concentration is called parts per million, and the equation is mass of solute over mass of solution times 10 to the power of 6. Remember, the M here stands for million, and 1 million is 10 to the power of 6. Now, once we've got that under our belt, the next one should be pretty easy. It's called parts per billion, and the equation is mass of solute over mass of solution times 10 to the power of 9. Again, the B here is for billion, and 1 billion is 10 to the power of 9. Alright, so we've got a bunch of different concentrations available now for different situations, but the truth is that the concentration you're going to be using the most is molar concentration, which we're going to talk about now. Molar concentration is represented by the letter C, and its equation is moles of solute over volume of solution. Notice that we're still solute over solution here, that doesn't change. But we usually just simplify the equation to C equals N over V. The unit for molar concentration is moles per liter, moles is moles, and volume here is liters. Notice that it's different from the unit needed for volume in mass volume percent, so just be careful there. Alright, question time. What is the concentration of a 100.0 milliliter solution in which 30.03 grams of glucose is dissolved? Well, first, we've been given volume, so that's 100.0 mils, but we can see here that we need volume in liters, so we'll use unit analysis to fix that. Essentially, I'm multiplying by the ratio of liters to milliliters, so for every 1 liter, there's 1,000 milliliters. Notice that the milliliters cancel out, and I'm left with 100 times 1 divided by 1,000, which gives me 0.1000 liters. You're also more than welcome to change units using the ratio method I showed you for converting particles. It works the same way, or you can use whatever method you're most comfortable with. Next, I've got the mass of glucose, which is 30.03 grams. But I don't need mass for molar concentration, I need moles. So that's just a quick conversion. I've got the chemical formula for glucose right here, so my molar mass is going to be 180.18 grams per mole. And in case you need some help with determining molar mass, we've got a link to a tutorial in the description below. So looking for moles, it's my mass divided by my molar mass, which gives me 0.2500 moles. And to finish it all off, molar concentration is moles, so 0.2500 moles, divided by volume, so 0.1000 liters, which gives me 2.500 moles per liter. And that's that. As always, if you have any questions, just leave them in the comments below. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.